Hi and welcome. My name is Daniel Kopp. I will talk about cybersecurity in OT technology. And first of all, I would like to present myself, and also my company. I have a master's degree in informatics, and I'm working for Danfoss. It's a huge company. It's a Danish company with about 40,000 people. But we are here, have a location here in Südtirol with around 90 people, where 40 are working in R&D. And we have a lot of competences, yes, but we are experts in creating servo drives, so motion, and frequency averters, so we know a lot about motors and so on. We also have some topics like functional safety, but we are not experts in cybersecurity. That will become important later on, and I will then say why. To introduce our product, what we are doing, so that we understand later on what I'm talking about, we are developing this part of the devices. So we have servo drivers controlling motors. In motion applications, we are developing all the parts by ourselves, so except the motor, we have the electronics, the mechanics, and also the software. We are doing also the product management and everything by ourselves here on site in Burgstall. Some applications, we are in industrial automation, so we are doing something like capping, labeling machines, but we are giving our devices to them, and they then develop machines out of it. So we just give the pieces, and then here we see some. They are connected together and creating a network on its own, and then they are in this industrial setup. Okay. First, what is the difference between IT and OT? So most of you know what IT is. All of you are using it daily, probably. It's PCs, smartphones, tools for email, finance, HR. So it's mostly devices are off the shelf, like you go into a store, buy your computer, buy your smartphone. They are replaceable. So if your PC breaks down, you go buy another one. And maybe if you have a cloud, all data is backed up. And the lifespan around 3 to 5 years, so not that long in most cases. In OT, as I showed you before, so if I go shortly back, we are in an industrial application. So we are talking about manufacturing, mining, oil, gas, and so on. Devices usually are purpose-built, so also maybe especially for one single client. They are not going into any store and buy it. We are going to them, and we, together with them, develop devices. They are highly specialized, so they are for this special environment. So in our case, they have some protections against water, against soap, and so that if they are washed or a bottle are breaking, the device is not breaking. And lifespans is way longer than in IT, so we are talking not about 3 to 5 years, we are talking about 10 to 20 years of a lifespan of a single device. And replacing sometimes can become very difficult, so you're not going there and say, okay, I can replace the hardware, and I cannot even, in most cases, replace the software. So if vulnerabilities are found, it can become really, really hard to do an update, because most clients do not say, no, I don't want to have any updates, because don't touch a working system. There's a history in cybersecurity of OT systems. In the last decades, I think cybersecurity in OT systems was not considered, if we are not talking about power plants or nuclear plants, because why should I protect a device which is behind a lot of firewalls, behind the IT? So they relied on IT security to protect the OT security. But we also see there have been quite some attacks, small attacks with DDoS, but also attacks against national nuclear systems that affected our world. And therefore, as the presenter before me, Carlo, explained, the Cyber Resilience Act, it was introduced last year. They have been working on it quite a while to define it, and it's a framework to enhance cybersecurity standards in Europe, only in Europe, for all products that have digital components. And it requires the manufacturers to ensure this cybersecurity through the entire life cycle of a device. So from the first design until it is produced and then also delivered to the customer, and you have also to do it afterwards. So you have to guarantee 10 years of updates in cybersecurity. And as I said, we are developing hardware and the software. It applies to hardware devices and software, so to both. The why should be clear. It's like we have low cybersecurity in digital products up until now, and there are not that much of security updates done in OT world. And the other thing is the poor user awareness. So we have in the area of OT systems, the awareness of cybersecurity threats is really poor. So they made that simple core idea that making this world secure by design, so not just somewhere now I need to implement something, but from the beginning it should be secure by design. But for each company, this introduces a huge challenge, which is a legal complexity. So we have to go to a lot of legal things. And as I said, for us, it's also that really complex because we are no experts in cybersecurity. I think in my company, I'm one of the people with the most cybersecurity expertise, and my expertise is 4 university courses 7 years ago. So, so I'm talking about Merano. Then in the whole company there are some, but you see we are experts in our field, but there is no expert in any area of cybersecurity. And then also, because we are just giving a component out, every time I'm talking with somebody, it comes back, we don't want cybersecurity because it adds complexity to our customers. And then I hear, okay, I don't want it, but I have to say, okay, but we have to do it, and you need to follow also this Resilience Act. Shortly about the standard itself, it is a bunch of documents. It's split up in 4 pieces. So we have the general part, we have policies and procedures, which the first 2 are some documents which are valid for all kind of companies. Then we have the system level, which is then like machines, complete machines, like the bottling machine, which our customer is creating. And then we have components, and we are here. So our product is a component, it's just a single device. A PLC, if you know what it is also, it would be also considered as a component. And then wherever you fall, you have to follow different rules and requirements. So there is the standards itself has written the requirements already, but they are really, really general. So if we take a look to the next 2 slides, there are different products in scope and out of scope. So we see there are always 3 rules to follow to know if you are in scope. So for example, a coffee machine which is not connected to any network, directly or indirect, is not considered. But you have headphones, you have some clocks, digital clocks, smart keyboards. Our product, a drone, would be considered yes, if you sell it on the market. But if it is like a university project or you have it only inside your company and you don't sell it, it's not considered. And now you see all these different products, and at the moment the same rules apply mostly to all of these devices. So it's really general, and people are it's really hard to know what you should follow, what not, because implementing encryption on our device can become hard because you have some microcontrollers and the performance is there to move the motor and not to do some encryption, decryption. On a keyboard, I don't know how much a keyboard performance has, but I think authentication and so on can become quite complex in that case. We heard before about open source, that it can help to support cybersecurity. At the moment, if you are open source project and you don't have to consider the CRA, it is out of scope until you introduce open source libraries in a commercial product, as we are doing. Then at the moment as it is, open source increases our complexity because it's on our side to follow the obligations, to do static code analysis, to if there are vulnerabilities, we have to report them that they are inside our product, and it is not done by the open source library because they are not forced to do such, follow this Resilience Act. And now there's always a hype now, yeah, nice, cybersecurity, a lot of technology, a lot of action, I can implement a lot of things. I have now worked since a year on the cybersecurity project, and I have not written a single line until today. It's just documentation, writing requirements, talking to people, talking to customers. Now I'm at the step planning the architecture. Then we have to create the design of software and hardware, and at the very last we can start to think about implementing coding and working on the really cool stuff. But you see, most of cybersecurity with the CRA is about, do I comply with the standard, is documentation such. But there are also some nice things. One is the threat modeling. For me, it was something really new. It's so everybody is doing it, I think, mostly every day, but not in a structured way. So threat modeling in that sense is a structured way to find, in a proactive way, threats and vulnerabilities. So you should do it already early in your concept phase if you know what it is. Every time you introduce new features, every time security incidents occur, or you change your architecture. And it's always the same. You have 4 questions. What are we working on is the first stage. So you define a model. What can go wrong? So what attacks can somebody do? What can go wrong? What will happen? Then, if we know that, what can we do about it? And at the end, ask yourself, did we do a good job? Have we found everything? Is there anything we missed? As I said, most people do it in their lives more often. If you have an apartment, a house, I think you think about, okay, is there any vulnerability? Can I close all the doors, all the windows? If we become a parent, like, are there any chemical storages which the child can access? Is there any high places, unstable furniture? Is there some water which can run out so that I have the flooding in my house and so on? So you see, threat modeling can be applied not only to software and hardware, but also to houses. More technical example, you have some architecture with some access from the outside. You have some credentials stored in a database. You have HTML access. And then one way to do it is using the stride. So different methods to find the threats. It will help to go through all of the single entry points of your system and decide if you have vulnerabilities or threats that can be found. The presentation will finish now. I will just take the last minute I have still. We are here in Postal, we are Danfoss, we are developing from software until hardware, everything. We have a lot of domains. We are working on communication systems, we are working on real-time systems. So if you're interested, here's the mail. You can send us if you are interested in internships or also bachelor thesis, master thesis. The same email can be found outside on the job offer things. And later on, we have a workshop with my colleagues about motion control with OPC UA. So controlling our devices using OPC UA and PLC. And then there will also be a talk about OPC UA. Thank you for your attention.